Hello, MongoDB Live, and welcome to my talk, Discovering Customer Signals in Online Retail. Technology and how we handle data has dramatically changed in the last 10 years, and to be moving data and adapting a hyper-personalized approach is now becoming the norm. We're going to be using the time today to talk about this from the perspective of online retail, and some of the decisions and approaches we've taken and the technologies we've adopted to help us. When thinking about how our customers interact with us, they're consistently sending signals to us all of the time. If we take the example of someone sat on AO.com and they arrive on site, they select a category, they open product lister, they can filter on prices, they can select a product, navigate through the gallery of that product, add that product to their basket, and effectively end up at the point where they've gone on to purchase with us. So they're consistently sending signals around what they're interacting with, what they're doing, and it's up to us to open up a mechanism to capture these signals and use that to personalize their experience. Otherwise, if we don't, we're effectively taking all of the signals that our customers are sending and letting them fall into a bit of a black hole where we can't use it to give them the real sense of the fact that we're trying to give them a great experience on AO.com. So I'm going to set the scene a little bit. What I'm going to do here mainly is introduce myself and AO. We're going to take a brief look at the retail landscape, both on the high street and the challenges that are being faced. We're going to look at how consumer expectations have changed, what they're expecting to see, what they're expecting from personalization. And then we're also going to take a quick look at what's needed to enable personalization within an organization. So to start with, I'm going to introduce myself. My name is John Vines, and I'm an engineering lead at AO.com. And I've got a focus on data integration and enabling event streaming across the organization. I've got over 10 years experience designing, developing, and delivering software products into production. And I'm also a massive proponent of DevOps. And as part of that, I'm a co-organizer at DevOps Manchester, which is a community meetup here in Manchester to bring together DevOps enthusiasts. So who are AO.com? Well, we're an online electrical retailer, one of the largest in the UK, providing electrical products and related services to our customers. We sell major and small domestic appliances across the UK and Germany, and also ancillary services such as installation of new and collection of old products. We operate across a number of categories, including MDA, SDA, AV, and a few others. And as of 2018, we broadened our mobile phone offering with the acquisition of Mobile Phones Direct. We're also super proud of our AO Recycling, which is a waste, electrical, and electronic equipment processing facility. And this is one of the largest in Europe. So coronavirus withstanding, what was the retail sector facing, particularly the high street facing? I think it's fair to say that retail was facing a really difficult time, both before coronavirus, but certainly exacerbated since then. And what we've seen as part of this challenging time was a number of retailers who, unfortunately, have had to close business because the number of sales through that footfall through the stores was declining. And as part of this, there's definitely been a trend to online. Established names that we already know about having an increasingly bigger online presence. And there are a number of other startups who are operating exclusively online. Our business here at AO.com is exclusively online. We don't have a shop footprint. And this trend to online creates opportunity for disruption of the market, opportunity for us to view things in slightly different ways than perhaps we would have done before. We're also subject to this disruption, even with our online presence. So we need to be well positioned to take the opportunities that are being presented as well. It's also fair to say that consumer expectations have changed over the years to the point where a lot of customers and consumers these days expect there to be some level of personalization throughout their online transactions. We can see this in the number of stats that we've put together on this slide. So 3 out of 4 consumers expect companies to understand their wants and needs. 3 out of 5 expect companies to adapt based on their actions and their behavior. And 1 in 5 are happy with that level of personalization at the moment. So there's a real disconnect between what consumers are expecting, what customers are expecting, and what in general is being offered to them as part of that. And quite surprisingly, to some degree, is that 9 out of 10 consumers are willing to share their data to get a better, cheaper, and easier experience online. We can see this in some examples. We're going to use the probably classical example of the Blockbuster story and the emergence of Netflix. And that experience of renting videos has dramatically changed in the last 20 years. Initially, you would have had to have taken yourself to a store like this one in the top left, find the section with the types of films that you were perhaps interested in, and browse through each of those films to find the ones that you really wanted to watch. Nowadays, it's obviously a completely different experience. Using the Netflix example, this is an experience that is hyper-personalized to the point where we have a percentage match to tell us how much Netflix believes we'll like a particular program, to offering what we might want to like or watch next as well. But we can also see it in some other day-to-day types of activities, taking, for example, your grocery shopping. And in the same way that we'd have to browse the shelves in a video store, we have to do the same every week doing our weekly grocery shopping. This means that we need to know whereabouts in the shop we need to go to get the stuff that we need. And we can also see that there's a trend for online grocery shopping where we can start to bring in these elements of hyper-personalization that increasingly improve the experience that we have shopping online, using our previous shopping experience to give us experiences such as the one in the bottom right, asking us if we've forgotten certain products that we usually buy. And while all this sounds great, there's also a potential negative impact here if we get things wrong. So, for example, if you're a vegetarian and we start offering meat goods on this particular page, such as the streaky bacon in the top right, or the Parma ham that we can see, that would be something that could negatively impact our experience at checkout. So what do we need to do to enable personalization? I think to start with, it's pretty important that we understand where our data is coming from. So there are many sources of data, both internally within our organization, but also externally as well. There are available data sets that give us great context as to what is happening. And it's important that we do give our data context, which allows us to improve that experience over time as well. An example of this context is the cost of a product at a particular given time that a customer was interacting with us through the website. It could also be active promotions. It could also just be the time of the day. That context really drives the types of experience that we can give back. We need to make this data available across the organization as well. So not only do we need to understand where this data is, but we need to make it accessible so that we can find out these new behaviors and what we're seeing our customers do to interact on site to generate experiences that respond to how they're interacting. But perhaps most importantly, for online experiences, we need to be responding in real time. We need to get access to that data as soon as it's happening and generate experiences and insights based off that data whilst it's happening as well. This is particularly important for online experiences. A delay of even 5 minutes might mean that the consumer or the customer has left the site, which is obviously a missed opportunity. So now we've outlined who AO are, what the challenges on the high street are, and what consumers are expecting these days. I'd like to take stock and gather some of our thoughts around how we can tackle this problem. In particular, we'll start with the single customer view. We'll then talk about why that's an important part, but perhaps not the only part, and how events and being event-driven can take us towards that more real-time opportunity to provide new experiences for our customers. And then we'll talk about what being event-driven means for our customers. So the single customer view data. This quote comes from I think it was a Forbes article, and it describes that data is central to the single customer view. That organizations require to better understand their customers and tailor hyper-personalized engagement. And I think it's quite easy to draw into this statement that single customer view makes it feel like there's one big pool of data. So if we start to ask ourselves, what is the single customer view and what are the important pieces, we find ourselves asking a number of questions, such as, is it just a big pool of data? What data is appropriate? What is a customer? Is it someone who's transacted? Is it someone who's just turned up on site? Is it someone who's phoned the call center to get a little bit more information? And when considering the single customer view as one big pile of data, what we found was that each business unit, perhaps unsurprisingly, had different needs and demands on what SCV could offer. So we then started to think about what that means of there being a single repository for customer data. And as part of that, we start to think about what data held within a database represents. And we see that that describes state at a given point in time, usually the point in time that we're at now. This means that we've done a few things. It means we've defined what a customer looks like up front. We've defined where that data comes from. It's harder to impose new views on this data from a historical context, and that makes it harder for us to understand what happened in the past. So we wanted to switch the paradigm a little bit and start to think about events and using events to build an ecosystem where we can build the appropriate view for a given stage of the journey that our customer is having with us at a given time, but also to go and historically analyze that data so we can look for behaviors and trends at a more global scale to give a better experience. And by adopting events, we can describe the series of actions that a customer has taken to get to a given point in their journey. And this changes the consuming communication options that we have as well. So let's describe an event. This is a dictionary definition of an event, and it's essentially something that happens, especially when it is unusual or important. If we switch this into what it means for an organization, an event is something that happens that is important to that organization. And we can find that we can use the language of events to describe exactly what's happening across an organization as a whole. So what are some sources of events? Well, events come from everywhere. Perhaps the easiest place to start is to think of a customer completing a purchase. That order confirmation is an event that is sent when a customer gets to the end of their purchasing journey. But an event is also when they've clicked on the product. It's also when they've received an email to get their order confirmation. It's almost also when they receive an email to say that their product's out for delivery and that the van is just around the corner. And the delivery van location is another event. So each time that delivery van moves, there's an event that's produced to say, I am now here, I am here, I am here. Perhaps the classic example of where location of a vehicle is used in a huge way is apps such as Uber and Lyft that tells you where your taxi is around the corner so that you can be outside and you're ready to start your journey. And then finally, we've got system events. So this is things that are happening within the systems themselves. And what I like to think about here in particular is the field of observability and building in, instrumenting your code to describe what is happening within those systems at that time as well. There are also a number of different types of events. The most basic type of event is event notification. And this is essentially just an event that is raised which states that something has happened. Any consumers of this particular event would know that something has happened for a given entity, but they'd have to go back to the source system to get the state of that entity at that time. The challenge with this is if event notifications are delayed and the state has changed since that event was sent. But it's a good way of just letting other things know that things have happened across the system. The next is event carried state transfer, and this is an extension of event notification. It can still be used for notification, but we also pass along all of the data required to understand the state of the given entity that has been updated as part of that event. This gives consumers the opportunity to do whatever they need to with that data and not have to go back to those source systems to get the data they need. Extending on event carried state transfer and going within the applications, inside the applications, is event sourcing. And this is where we use those events to build up the view of the data, the state of the data at that time, given the events that have previously happened. This allows us to replay those events within the application as well. For the rest of this talk, you can assume that we're going to carry on using the example of event carried state transfer, which is an enabler for not only event sourcing, but also some of the event streaming paradigms that we'll discuss a little later on. So what does all this mean? So for us, when we think about events, we're thinking about these events capturing the signals that our customers are sending. So each of those clicks, each of those brands viewed, each of the products looked at, the average cost of the products they're looking at, and many, many more. And we can start to build these customer profiles within the context of pricing, promotions, and other useful events occurring across the organization. So now we've taken a look at the context of the world we're working in at the moment and how we want to represent what is happening across the organization, but also across what the customers are doing and interacting with our products as events. We can start to take a look at the data and what this means. So each of those events that we're talking about, each of those customer signals that we're talking about, we can describe as an interaction event. This is an interaction event that we capture every interaction our visitors are having on site. So every time they click, we capture the context around where that specific click happened and provide an event as part of this. So this can be a page visit, it can be clicking on a gallery, for example. And ideally, we're capturing enough context for us to understand what they've done as part of that event as well, so that we don't have to go back and work out or infer what's happened as part of that event. This gives us some good opportunities to analyze for trends at a macro level. So trends across groups of customers, and we can see just in general how particular things are performing. But also more importantly, it allows us to analyze for behaviors at a micro level, so an individual user, and it's through this analysis that we can start to generate that hyper-personalization for a given customer. And perhaps most importantly, we can use this analysis to respond to these emerging behaviors for better customer experience. So we can start to listen for the signals, look for the things that are important for a given customer, and provide a personalized experience back to them as part of that. This opened up some challenges for us on how we store these interaction events. And there were a few options that we had to consider as part of this. The first is perhaps the natural inclination, which is to store a document for every interaction that comes into the site. What we found with this approach was that this inevitably led to lots and lots of documents. This meant that it was hard to aggregate because these interactions that were coming in were sporadic. There wasn't an expected lifetime of a session, or we'd see bursts of events and then very long periods of no events before a session continued as well. And this also meant that there was lots to store in our indexes, so query was impacted by this as well. The other alternative was to just use one document and capture an array of all the interactions for a given session. This also introduced some challenges. The document, the amount of interactions we'd see through a session could be unbounded. That session could continuously grow. And we'd end up with very large documents. And this also makes for slow queries. The bigger that document gets, the slower the query gets as well. So we found our solution by using the bucket pattern with MongoDB. And bucketing can be done in a couple of ways. We can time bound it. So within a given period, perhaps a minute, perhaps an hour, perhaps even a day, we'd create one document where all interactions within that time get stored within that document. And then once we move into the next transition of time, we create a new document at that point. But we actually decided to go with a quantity-bound one. As we spoke about, those interactions could be sporadic, but by going quantity-bound, we could cap at what size we expect those documents to be. This had some advantages and some disadvantages. By using this size-based bucketing, we can give a practical size limit to a document model. And once we exceed this size limit, a new document can be created. This is still very efficient with resources. It means that we're not targeting potentially hundreds or thousands of interactions, and it means we're not trying to pull one massive document out of the database. And it's suited to that irregular updates that we can see with some of the behavior patterns our customers and consumers exhibit. But it also helps to prevent out of bounds growth as well. So we know that a document will finish at one point and it will create a new document from that point on. But from a disadvantage perspective, it can still result in a large number of documents if the frequency of updates is high or the array count is set too low. So understanding what an optimum size is, spending the time to work out what that looks like for you is super important. We can start to take a look at what it takes to apply this bucketing pattern. I've split this into 3 sections. So we'll look at how we target the document we want to update, what an update looks like, and then finally, how we execute that command into MongoDB. So to start with, we're building 2 separate filters here. The first one is to target the document that we want to update, which is the session in this instance. And the second one is where we filter based on the bucket size of the latest document that we're updating at that time. So in particular, we've got a predefined bucket size, and we check for a property on that document to see if the interaction count already stored within that document is equal to or greater than that bucket size as well. We can then combine these filters and start to think about our update. Our updates look a little bit like this. So there's a few things going on in here. We can update values on creation only, and we can also update on every interaction. So where we use the command set on insert, this will only insert those values on creation of the document. What's particularly important here is that we set the date on date inserted, and we don't expect that to be updated from that point onwards. Conversely, using just the set command, every time that document is updated, we can increase the last updated date as well. We've also got 2 other commands here, which is add to set, which allows us to add the interaction that has just occurred to that document. We also increment the interaction count for that particular bucket as well. So every time a new interaction is stored against that document, this interaction count grows, and we use that as part of the filter to determine whether we need to create a new document or not. Finally, we have the update command, and this is exactly the same as any usual update command that we'd see in MongoDB. So for this particular command, we combine the filter, the update, and we set the isUpsert option to true because there are only certain parts of that document that we're updating at that one point. And if it turns out that we've exceeded the interaction count, we then go on to create a new document as well. So all this is well and good. We've got a method of capturing these interactions and storing potentially numerous documents to describe that interaction. But what we really want to see is an aggregated view of this session and what it means from a top level for that given user at that point in time. So each time an interaction occurs, we use the aggregation framework to create an aggregated view of the session and produce that as an event as well. By using the aggregation framework to create this view, we can scan across the documents that we need, create the high-level view of the different types of pages, the different types of brands, publish the aggregated session view for downstream use. This opens up some interesting thoughts, particularly around how we use machine learning models. So to start with, we store each of these session statistics in S3, and we can use this for data exploration, but also for training models for the future to decide what kinds of unique personalized experiences we want to give back to our customers and consumers. By doing this, we can define and extract features from this data set, and we can start to extend that session stats with these new aggregated features that we're pulling out from the historical data in the offline world. The benefit of this is that we can use the same models for online execution. Because the data models are the same, the challenge of trying to understand how and where we define those features is minimized, which means we can bring new models online quicker. Within this space as well, we also have the opportunity to use Atlas Data Lake. If you're not sure what Atlas Data Lake is, it's the MongoDB query language over S3. And this enables us to use the MongoDB query language that we all know and use every day with MongoDB for data exploration over other file types stored in S3. So this can be JSON, it can be BSON, it can be Parquet, it can be Avro. And this is really intriguing because it then allows us to build the same query for offline exploration, but also take that query that we've built for that exploration and use it as part of online execution as well. Whilst this is something we're super excited about, we're keeping a close eye on it. It's still in beta, and we're still working out ways that this can become a really big part of our model training and data exploration pipeline. We can also use MongoDB to monitor the effectiveness of the models that we produce and put out into production as well. The example in the bottom right is of one of the charts in MongoDB charts that we use to determine the effectiveness of a given model in production. To give you a flavor of what these values mean or what we're looking for, the graphic in the top right corner is something that is known as a confusion matrix. And this is a way of plotting the accuracy of a given model based off the number of true positives and true negatives and the false negatives and false positives. And we use this to define where there is potentially missed opportunity or where there's waste within a given model and the goals that have been set for that particular model. To make this even more effective, we can aggregate that model accuracy based on the time that it's being invoked on site as well. And the charts in MongoDB is one way that we can see this. And to make this even more effective, we can see these results in real time as they're coming through. So if there's a dramatic decrease in the effectiveness of a model, perhaps given because of market conditions at a particular time, we can change the types of experience that we're showing based off the models that are there in production. So that's a little bit of a flavor of some of the stuff that we're looking at the moment. And it's important for us to be thinking about what our next steps look like. So we'll talk through now a little bit about MongoDB and where events and MongoDB fit together. We'll take a look at some of the use cases and results that we've looked at so far. And then we'll also have a think about some of the key takeaways that I'd like you to take away from this talk today for you to think on in the future. So MongoDB and events. Because MongoDB stores its data in BSON format, What we found was that the structure of data of the documents that we store in MongoDB closely matches the structure of the events that we see as well. There's also the opportunity to monitor the inserts, updates, and deletes to generate events from MongoDB. And this is something that we can start to keep in mind when designing event-driven services. A feature of MongoDB that I'd like to talk about first is change streams. So change streams allows us to monitor that update, insert, and delete of data and subscribe to all of the data changes on a single collection, a database, or a deployment. And we can subscribe to that from a service that we've written and then react or respond to those changes as they're made. Because it uses the aggregation pipeline, we can also filter for specific changes or transform those notifications as they come out of the database as well. To create a subscription to a change stream, there's not a huge amount of code that we need to write. This example is taken from some of the documentation online. But the problems that we have with this is that for every new consumer that we want to bring online, we have to create a subscription as well. So if the limit of what you want to do is constrained to one service, or it's constrained to within the capabilities of a given team, then change streams is a great way of getting the updates, inserts, and deletes out of your MongoDB database. But we use Kafka. All of the events we publish are to be made available organizationally, not just within the team that they're produced from. And to help us get our events into Kafka, we could use a change stream application, which takes those streams and produces a Kafka event. But we can also use Kafka Connect. If you're not familiar with Kafka Connect, it's a framework for connecting Kafka with external systems. In this case, for connecting MongoDB as a source and pushing those events into Kafka. Conversely, the fully supported Kafka Connect for MongoDB connector can also take data from Kafka and put it into MongoDB as well. There is a fully supported Kafka Connect for MongoDB connector that we can use for sync and source connectivity. And we found that this is a great way for easily capturing events generated within a system that are stored to the database and removing the challenges of dual write that occurs as part of that. What I mean by dual write is if we store to the database and then subsequently produce an event from within code, there are two opportunities for failure within that particular transaction. One at the point of storing to the database, but also one at the point of publishing to Kafka as well, or publishing to your event framework to be technology agnostic. By using Kafka Connect, we can remove that problem by subscribing to the insert, update, or delete within MongoDB and publishing that out as an event once that store has occurred. We can also use pipelines as part of this as well, using the aggregation framework to do some transforms so that we generate the shape of event that we're expecting to see. So what does all this look like for AO.com? So we've built a few use cases around using our clickstream data provided by our customers, the signals that our customers are sending us, to provide some use cases that are specifically tailored to their needs. This can be around delivery proposition, it can be around promotions, it can also be around the types of brands that they're interested in. We can use this data to understand where they've come from, what they're doing on site, but also what things look like for them after they've purchased. So taking the order they've done and following that through both delivery, the aftercare, and retargeting from that point onwards as well. And interestingly, we're also starting to experiment with our logistics part of the business and understanding how we can tie in use of the data that we produce both within the warehouse but also with our vans to create individual unique experiences throughout the order delivery proposition as well. And we've seen some really interesting results as part of this. For some of the experiments that we've run, we've seen some massive indicative increases in sales growth, but we've also seen that we need to be constantly adapting to the signals that our customers are sending. We've reduced model delivery time, and we're continuing to work in this area. But we can also monitor real-time results using MongoDB charts in a way that gives our users within the business the opportunity to see what they need to see when they need to see it. So in summary, we can see that the landscape of retail is changing massively, particularly now. Our consumers expect a personalized experience, and they're willing to give their data for a cheaper and better experience online as well. We can also see that consumers are consistently sending signals for us to adapt to and understand, and it's up to us to capture those and use them to give our consumers and customers a better experience. We also want to embrace events, decouple systems, and create opportunities for us to give those experiences to our customers and consumers. And we also can use events to reduce the disconnect between offline training of machine learning models and the online execution of those models, providing those experiences as well. So as we've demonstrated throughout the talk today, we can see that our customers are sending us signals all of the time. So it seems that we've got a choice. We can either let these signals disappear into the ether, down the black hole, for them to each have an experience which is the same as every other customer that appears on site for us. Or we can say, hey, we hear you. We know what you're looking for. We know what you care about. Here are some experiences that are specific for you. So thank you very much. My name has been John Vines, a software engineer here at AO.com. You can get in touch, ask questions on the chat, or find me on Twitter @_John Vines or LinkedIn John Vines. I'm looking forward to speaking to you soon. Bye now.